where the area or the probability, and we call this one P because we're going to be starting about p-values soon, under the normal curve is to the right. Sorry. Of this C. Okay, I think my English is okay there. I may be missing some words, but let me draw this out for you. So if I want some particular area under the normal curve P, and I'm going to the right of some value on the horizontal axis, the Z value associated with that P is called a critical value. So let me show you how we'll use this with confidence intervals. Let's do 90% confidence. We haven't done this. Okay. So let's think of what 90% confidence, let's think of what the normal curve associated with that one is. So if I'm 90% confident, I got 90% of the area out of the middle. How much area is over here in this right tail, as it is called? Okay. So for 90% confidence, I want to find the Z star, I want to find the critical Z for 5%. Okay? Give me some ways that you think you could find that Z for that 5% mark. Inverse norm. What do you put into inverse norm? 0.95. Okay. And what do you get? Okay. Let me tell you a couple of other places you can get this. First off, why did we do inverse norm? Because inverse norm takes, if you do the area to the left of your value, which would be 0.990 plus 0.05. If you push that into inverse norm, it tells you what the Z value is right here at 95 to the left and 5% to the right. Because inverse norm takes as its argument area to the left. Yeah, so you have to do 100 minus 0.05 or 1 minus 0.05. Okay. Let me show you other places to find that number. Here is a hard place, Table A. If I'm going to use Table A, I got to go into Table A and I got to find 95%. 0.9505 is pretty close. So that gives me 1.65. Okay, a hard way to find the critical value, but sometimes you'll have to end up doing it like that, or inverse norm is the easy way to do it. Or, in the back of your book, you have a table C. On this table that came from an AP exam, it's called Table B. It's called a T-distribution, critical values. If I go to the very bottom of this table, it says confidence levels. If I go to 90% confident, it says 1.645. So that's in the back cover of your book. Okay? So and these are the critical Z's. And you look on the infinity line to get the one that you need for the normal distribution. Oh, we'll get to the t-distribution in a few more days. It's called degrees of freedom, is the left column. Degrees of freedom. Teenagers are always thinking about degrees of freedom. Okay. Freedom. All right. Oh, because you've done chi-square, so you know degrees of freedom from that. So my critical Z for a 90% confidence interval is 1.645, no matter where you get it from. Let's try a 95% confidence. We've been doing that one, and so how much area do I have? Boy, that was like badly done. Let's try to get those. There you go. That's better. All right. So what's the areas and the tails? Yeah. So if you went to find your 95% confidence level critical Z using an inverse norm, or using the table in the back of the book, what number do you get? I call it 1960 because I can relate a little bit to that year. Not much. I was pretty young, but you know, I can do 1960. So this will be the one that you'll memorize because you'll use that one a lot. Now, yesterday we said 95% confidence was 2 standard deviations. Well, it's actually 1.960 standard deviations. So that's the one we'll actually use. We want to be a little more accurate. Okay, so there's critical values. Second distribution, and it's number 3, I think. Okay. Now let's do our famous 4-step procedure for a confidence interval. All right. Now, whenever you are asked to do a confidence interval, you do these 4 steps. If you leave one out, maybe sometimes you'll get the answer correct, but often you won't. So follow the 4 procedures. It's a really safe way to do these. Step 1 of the procedure is to name your parameter and your population. And you just say of interest. That'd be the one that you're studying. Step 2 is to name the procedure and check conditions. Step 3 is to do the math. And you only get to do the math if the conditions are met. And step 4 is to interpret your results in context. Okay, so we got your, can you grab that, Brian? Thanks. Just say Miss Gould's room. Of the United States. They gotta talk to me? Jeez. Don't they know that we're recording?